In the previous video, we looked at the time class, which was defined over a univariate function f, meaning a function that takes in a single variable over the set of natural numbers. Then the time f class has all those languages that can be decided in big O of f time, or equivalently, all those problems that can be solved in big O of f time by a deterministic Turing machine. And we know that there are uncountably many time classes, just as there are uncountably many functions. And this is too big and unwieldy to work with. So we can now say, why not group some of these time classes together? Let's take all the time classes that are defined over a polynomial and group them together. This class is called P, as in P for polynomial. We can formally write it as the union of all the polynomial time classes. So what's special about the P class of problems? One way to answer that is to say that it contains problems that can be solved efficiently. On your laptops, mobile phones, and other computer devices, contemporary computers can solve these problems relatively quickly. Of course, it is unlikely that a problem that is in n to the power 100 will be solved efficiently on any computer. But it turns out that most problems that have been discovered to be in P can be solved in under n to the power 4 time. Which brings us to the next point. How do we decide membership in class P? Well, if you can come up with an algorithm that runs in polynomial time, then you can safely assume that the problem is in P. Here I am talking of algorithm in the contemporary sense of the word, such as an algorithm that can be programmed into Python. If you can come up with such an algorithm, then this algorithm can also be programmed into a Turing machine as well. Maybe it will be slower when it's programmed on the Turing machine, but it will only be slightly slower. Before moving on, please note that P can be defined using other equivalent models of computation, other than the deterministic Turing machine, as long as they are polynomially equivalent to the Turing machine. Furthermore, we are not sure whether a non-deterministic Turing machine is such an equivalent model. It should always be assumed that our discussion about the class P is based on the deterministic model. So what are some examples of problems in class P? Sorted list is an example. The set of all sorted lists is in P. You've studied several sorting algorithms that can decide this problem in under quadratic time. Another language is path, defined over tuples containing a graph, a source vertex, and a target vertex. You've studied path-finding algorithms such as Dijkstra that can solve this problem in under quadratic time. Another example is the matrix mult language, defined over tuples containing 3 matrices, where matrix C is the product of the first two. The matrix multiplication language can be solved. The matrix multiplication problem can be solved naively using basic arithmetic in under cubic time. In fact, almost any problem that you've encountered in DSA and DS2 was probably in P.